Section 11.2 is on rational functions. A rational function is an equation that has the form y equals p over q, where p and q are polynomials and q is not equal to 0. In other words, it's basically a fraction. You'll have a polynomial on the top and a polynomial on the bottom, and the bottom cannot equal 0. And since the denominator cannot equal 0, any value of x that makes the denominator 0 is called the excluded value. That's the excluded value of x that's going to make the bottom of your fraction equal to 0. So these first examples we're going to take a look at are having us find the excluded value for each function. So the first one is y equals 5 over x. Well, since the denominator can't be equal to 0 and the denominator is x, so x cannot equal 0. So 0 would be your excluded value for that function. For number 2, we have the function y equals x plus 2 over x plus 1. And we're not even going to worry at all about the x plus 2 on top. It's just the x plus 1. X plus 1 cannot be equal to 0. Otherwise, that whole denominator would be 0. So we kind of solve this just like we do a simple equation. So x cannot equal -1. And that's our excluded value. In other words, in this function, x can be any number except -1. And in our last example, y equals x over 2x minus 8. Again, my denominator, 2x minus 8, cannot equal 0. So I just solve that like an equation. Add 8 to both sides. So 2x cannot equal 0, cannot equal 8. And dividing both sides by 2, x is not equal to 4. So 4 is my excluded value. For this function, x can be any number except for 4. Now, we can also graph rational functions that are in a little more complicated form. And this form is y equals a over x minus b plus c, where a is not equal to 0. So a is going to be some number, not 0. B can be some number, and c is going to be a number. And of course, x and y will stay in the equation as x and y. The graph of this function has a vertical asymptote at the line x equals b. Remember from the previous section we talked about asymptotes. An asymptote is a line that the curve approaches but never touches. So whatever b is, there will be a vertical asymptote. Let's see, let me go ahead and draw. So there'll be a vertical asymptote, a line like this, at the line x equals whatever the value of b is. This function will also have a horizontal asymptote. So in other words, a line going like this at y equals c. So whatever c is, that's going to be the equation of that horizontal line. The domain of this function is all real numbers except for x equal to b, and the range is all real numbers except y equals c. So let's take a look at a couple examples here and let's graph these. So this says identify the asymptotes of each function and then graph. So the form for this was, let me go ahead and write it up here. The form for this was y equals a over x minus b plus c. And as you can see from this function, there's nothing being subtracted from b on the denominator, so b is equal to 0. And there's nothing being added at the end, so c is also equal to 0. So that means I'm going to have a vertical asymptote at the line x equals 0 and a horizontal asymptote at the line y equals 0. Because remember, my vertical asymptote was where x equals b, and since b is 0, that's x equals b. My horizontal asymptote was the line where y is equal to c, and c equals 0. Now here's the interesting thing about these two asymptotes. The line x equals 0 is actually the y-axis, because every point along that line has x as its 0. So I'm just going to go ahead and sketch that in here. That's the line x equals 0. And my horizontal asymptote at the line y equals 0, well, that's actually the x-axis, excuse me, because every point on this line has a y value of 0. So those are my two asymptotes. I'd like you to go ahead and sketch those. Now, in order to graph this function, I'm going to go to my calculator and do it. And I'm going to put in what the function was. So go to y equals, and this is going to be 2 divided by x. Hit the graph button. And I can see that the graph of this actually makes sense. Remember, the y-axis here is my vertical asymptote, the line x equals 0. And you can see that the curve approaches that up here and down here and never touches it. And my horizontal asymptote is the y-axis, the x-axis, or the line y equals 0. And you can see that the curve approaches that. So when we go ahead over here to graph this, knowing that I'm just going to kind of draw the curve like this, so it looks like what I saw on my calculator, making sure that I don't touch or cross the asymptotes. And then the last thing I'd like you to do is identify the domain and range. The domain is the set of all x such that x is not equal to 0. Remember, we said the domain, let me go back up here, the domain is all real numbers except x equals b. So since b is 0, x cannot equal 0. And the range is the set of all y such that y is not equal to 0. And remember from the previous slide, the range is all real numbers except y equals c. c is 0, so my range cannot be 0. And that makes sense. I can have any number be an x and any number be a y except for 0 for each of those. And let's take a look at one more example here. Here we have the function y equals x minus 2. Y equals 1 over x minus 2 plus 1. So my value of b is what's being subtracted from x on the bottom, so b is 2. And my value of c is the number that's being added on the end, so my c equals 1. So that means that I'm going to have a vertical asymptote at the line x equals 2, and I picked that up from my b, and a horizontal asymptote at the line y equals 1, and I picked that up from my c. So let's go ahead and draw in those asymptotes. The line x equals 2 is a vertical line through 2 on the x-axis. And my horizontal asymptote is the line y equals 1, and that's a horizontal line through 1 on the y-axis. And let's graph this on our calculator to see what it looks like. So I'm going to clear that out, and I'm going to have 1 divided by, now because I had a binomial, I had an x minus 2 in my denominator, I'm going to put that in parentheses. And that's saying that that whole expression x minus 2 is in my denominator, and then when I do a plus 1, that's out there on the end. So let's graph that. And you can see that this graph makes sense. This calculator didn't draw it, but you can see that there would be a vertical asymptote right here at the line x equals 2, and then there would be a horizontal asymptote right here at the line y equals 1. So again, my curve is going to be kind of to the up in the right corner and then kind of down in the left. So let's go ahead and draw that on the graph here. And remember, it's going to be inside the asymptotes and not touching it. And down here, something like that. And it's perfectly okay that this graph crosses the axes. It actually has to. The lines that it's obeying and not crossing are the asymptotes. And let's go ahead and state our domain and range. My domain is the set of all x such that x is not equal to 2. And my range is the set of all y such that y is not equal to 1. And those are the values that I got from my asymptotes. And actually, if you went back to the calculator and you took a look at the table, you could see that if you put in 2, you're going to get an error message. And for all the different x's you put in, you'll never get exactly y equals 1. So just to review, a few things to know about rational functions. There are excluded values, values that the denominator cannot equal, and you'll need to be able to find those. And you can graph a rational function that's in the form y equals a over x minus b plus c, identify the vertical and horizontal asymptotes, identify the domain and range, and then use your calculator to sketch a graph of that curve.